In this video, we are gonna introduce the issue of climate change in a bit of details and a bit technical presentation. What are we gonna cover or talk about? We're gonna talk about climate change, about the phenomenon itself, and what are the main drivers that causing climate change. We are going to also talk about the different types of climate variability, what can happen, and then we're going to talk about primary impacts, and we will finish this video with the topics to be covered in later videos of this series. When we talk about climate change, we have first to understand the concept of greenhouse effect. Greenhouse effect, it's a natural process that there are certain concentration of a number of gases in the top layer of the atmosphere that plays a role in controlling temperature on Earth. They allow sunlight into Earth and deflecting some of the sunlight outside, and also keeping some of the sunlight or the heat into the atmosphere. And that's why we normally have a limited difference between temperature between day and night, which is not the case in other planets in the galaxy. So that process is a natural process. What's the problem? The problem is, as the concentration of these gases increase in the top layer, they play that natural process, but with more effectiveness and efficiency. They are keeping more and more of the heat coming with the sunlight into the atmosphere, which leads to increasing temperature over time. That's simply the process of greenhouse effect. So when we talk about global warming, what are we talking about? We're talking about slow increase. We're not talking about sudden or very high increase in average temperature of the Earth and the atmosphere, but it's a slow increase, but over a long period of time that become substantial. That's because of increasing the amount of energy that's being trapped in the atmosphere and not radiated out into space. The same concept of greenhouse effect. Before we get into climate change, we need first to understand what is the climate system components. The climate system consists of 5 components, highly interdependent and highly related, which means that whatever happens in one of the components, a change will lead to changes and affecting other components. The components of the climate system include the hydrosphere, including oceans, lakes, and rivers, water bodies. It includes also the biosphere in terms of ecosystems, the atmosphere, the air, the geosphere, land, and finally the cryosphere. We're talking about ice and seasonal snow covers over the Earth. So as I said, whatever happens in one of the components will lead to changes in the other components. That's part of the problem. When we talk about climate change, we're talking about change in the climate. The different components interacting together. And when we talk about climate, we have to differentiate between climate and weather. whether we're talking about changes and fluctuations over short periods of time, while when we talk about climate, we talk about a long-term change in the climate. So if we look at the definition of climate change provided by the IPCC, Intergovernmental Panel on Climate Change, we're talking about a change in the state of the climate, whether we're talking about change in the mean or the variability, and that's important, persists for an extended period of time. We're talking about decades or longer. So the IPCC is talking about climate change, whether we're talking about change in the climate due to natural processes, or we're talking about changes in the climate due to human activities. When we talk about climate change as defined by the UNFCCC, United Nations Framework for Climate Change Convention, we're talking about a little bit different definition. We're talking about change in the climate that's attributed directly or indirectly to human activity. So for the UNFCCC, we're not talking about climate change in general, but we're talking about climate change which is attributed to human activities. That leads to alteration of the composition of the global atmosphere, in addition to natural climate variability observed over comparable time periods. As we said, we're talking about decades or longer. The main difference that we have to keep in mind when we look at these two definitions is that for the UNFCCC, it's about trying to get a convention between different countries into reducing the emissions of coming from human activities, which means that it's interested in the share of human activities into the emission and its influence on climate change, while the IPCC is talking about the change in general in the climate. Okay, that's the main difference between the two definitions, but at the end of the day, we're talking about changes in the climate over a long period of time that would lead to changes in the different properties of the climate. What is causing climate change? As we said at the beginning, we talked about greenhouse effect. And we said that as emissions and concentrations of these greenhouse gases into the atmosphere, that would lead to more increasing greenhouse effect. So the story, it's about greenhouse gases, ozone, clouds, aerosols. That's the main story that we're talking about. So what sort of gases are we talking about when we talk about greenhouse gases? First, we talk about water vapor, which is water in its gaseous form. It plays actually two opposite roles. One is that it's blocking some of the reflected sunlight from going into the atmosphere, and at the same time with the clouds, it's actually reflecting some of the sunlight from entering into the atmosphere and hitting or reaching the earth. So it's playing two roles. That's one point. The second point is actually water vapor does not persist in the atmosphere for very long times. So that's not the main issue that we are concerned about. What are we going to talk about now is three greenhouse gases, the most important ones. Carbon dioxide, which comes mainly from burning fossil fuels, and which is the most important greenhouse gas because of its radiative effect, and also because it persists in the atmosphere for very long time. The second one is methane, which comes from wetlands, growing rice and raising cattle, as well as using natural gas and mining for coal. That's the second most important greenhouse gas. And the third one is nitrous oxide, which comes from some types of factories, like the power plants, like fertilizer factories. And actually, it causes two problems. One problem is it damages the ozone layer, but it's also a powerful greenhouse gas. These are the three main greenhouse gases, and that's when we talk about greenhouse gases are the main ones that we focus on. There's also ozone and chlorofluorocarbons. So that's the greenhouse gases that we're talking about. Okay, so if we look at the concentration of these gases, the main ones, CO2 part per million into the atmosphere is increasing over time. The same applies to methane, and also when we talk about N2O, that's parts per million. It's overall the three greenhouse gases are increasing over time, and that's the main issue when we talk about climate change. What determines the emissions or the quantities emitted of greenhouse gases? There are a number of factors that would determine the magnitude of greenhouse gas emissions, including the first one is demographic development, which is we're talking mainly about population growth. Population growth means that we need to produce more, we will be consuming more, and also there are expected expansion of economic activities in order to meet such needs. The second one is the socioeconomic development. We're talking here about economic growth and land use changes. Economic growth means increasing production. Increasing production means existing economic activities are increasing the scale of work that they are doing, the processes of production, as well as additional economic activities being added to the economic base. And that would lead to increasing greenhouse gas emissions. Land use changes, and the main component when we talk about land use changes, we're talking about deforestation. Because of economic growth and population growth, that would lead to need for more land, and typically that would replace forest land and lead to deforestation. Deforestation is helping with the mitigation of the gases that being emitted in the atmosphere. The third element, which is technological change and energy system, we're talking about efficiency of technology and use of fossil fuels and or renewables. Efficiency of technology in terms of use of energy. The more efficient the technology in terms of use of energy relative to the scale of production, the better the situation is, because it means that we are emitting less greenhouse gases while maintaining or increasing our production. While the use of fossil fuels and or renewables, we're talking about the mix of fossil fuels and renewables that we use to generate electricity, to have more power and energy. And the more we use of the renewables, the less emissions we'll have in terms of greenhouse gases. These are the three main factors that affect greenhouse emissions. Okay, what has been going on? What sort of observations we have? And I should be saying that the fourth report of the IPCC and the fifth one they started talking about observations, and especially the AR5. They are not talking about what is going to happen in the far future. They are actually talking about things that are happening at present. Okay, so one of the observations is when we talk about global land ocean temperature index, we will find out that there has been changes in temperature in that index. But if we focus from the year 2000, we'll get that this is a sort of a trend increasing at a high magnitude in temperature. So what are we talking about? We're talking about since the first temperature, global temperature records started in 1880 and up until 2014, we have an increase of 0.7 degrees Celsius. And here some people would say, well, actually we're talking about 0.7, we're talking about a degree or two Celsius. That's not going to be that much. But keep in mind that we're talking about the climate system, we're talking about the different components, the 5 components we talked about at the very beginning of this presentation, and any increase in the temperature would lead to changes in the whole climate system. That's a concern. So if we also look at the 10 warmest years between 1880 and 2018, well, we'll find that 7 of the 10 happened during the last 10 years. One in 2005, one 2009, and 1998, which means that during the past 20 years, we're talking about the 10 warmest years happening during the past 10 years, about 10 years. That's a sign that there's a trend happening with the heating of the atmosphere and the earth. Okay. At the same time, precipitation trends have changed. If we compared the average between 1961 and 1990 compared to the year 2019, we'll find out that there are changes in precipitation in different areas. Some areas are experiencing increase in precipitation. Some areas are having less precipitation. But we also have to keep in mind in this respect that when we talk about precipitation trends, we are not talking about flash flooding. Actually, some areas would have the same quantity of precipitation falling within a very short period of time, leading to flash flooding. So the process is changing over time. Okay, so the variability of the climate. What do we mean by variability of the climate? When we talk about variability of the climate, we're talking about changes in terms of the mean or other statistics occurring, as well as the occurrence of extremes in terms of temporal scale and spatial scale, in terms of time and location. Okay, that's the story that we're talking about. So what term of variability are we talking about? We're talking about 3 types of variabilities. That's what we have here is the normal distribution or the usual distribution of climate events and the frequency and probability of happening. So we're talking about the first type of climate variability, which is shifting means, which means that the mean would shift into more hot weather and less of the cold weather. In this case, we're going to have less extreme cases of extreme cold weather, while we're going to have more hot weather and also more extreme hot weather events. For example, if we're talking about droughts, we would expect, according to this diagram, that we are going to have more extreme events in terms of drought compared to the extremes in terms of cold weather. That's the first type of climate variability. The second type is actually increased variability. The standard deviation of the curve is going to be changing. So we are going to have extremes, more extremes on both sides in terms of more extreme cold weather and also more extreme hot weather. That's the second type of climate variability. The third one is about changing symmetry, which means that the form of the curve will change as well as the mean of the curve. In this case, we are going to have changes in terms of, as I said, mean as well as the extremes. We are going to have more extremes. The shift would lead to the left, could be to the left, which is to more cold weather, and less to the right, or the other way around. So when we talk about climate variability, it can take different forms of change. Okay, there's one point that we have to keep in mind, which is nonlinearity. The processes that we're talking about are not simple. They are very complex in terms of cause and effect. Increasing temperature with 1% does not mean change in precipitation by 1%, or change in melting ice by 1%. Actually, it's a very complicated relationships in terms of cause and effect. So we're talking about nonlinear with very complex behavior, which means that actually we don't know exactly what's going to happen in the future. Some people talking about 4 degrees would lead to abrupt climate change, which means that the whole system will change in a way that we have never expected and we cannot predict. Some people talking about 6, whatever, but we are not sure. So the system can abruptly change, but we are not sure about that. Okay. In terms of climate change impacts, what are the primary impacts of climate change? We're talking about climate change, we're talking about increasing temperature, we're talking changes in magnitude and distribution of precipitation. The trends are going to change. And also we're talking about sea level rise. Sea level will be rising, and that's because of 2 factors. On one hand, increasing temperature, part of that temperature increase will be absorbed by the water. So we're going to have thermal expansion in the seas and oceans, meaning that the volume of water will increase. And also with the increasing temperature of the earth, we are going to have ice melting, which adds more water into the seas and oceans. That would lead to sea level rise, which can affect coastal areas, especially low-lying land, and also can affect the system of the natural system of the oceans and seas. Both we're talking about physical and biological systems of the seas and processes. So what are we going to talk about in here is very simple. The primary impacts, the main primary impacts of climate change is health impacts, impacts on agriculture. We're talking about impacts on forests. We're talking about water resources due to changes in precipitation. Water quality will be affected and water supply as well will be affected. Coastal areas, as we said, in terms of sea level rise, and also the wildlife in general, not just in the seas, in the marine environment, but wildlife in general. The point that we would like to note here is, actually, when we think about climate change, A lot of people consider that climate change is an environmental issue that has to be dealt with. But what are we saying is actually it's an environmental and development issue. Because what we can say is when we talk about climate change impacts, every sector you can think of will be affected by climate change. And that's why we're talking about development issue. I'll give you an example. In Egypt, we have the main attraction for foreign tourism is the Red Sea, the coral reefs, and the marine environment in these areas. With increasing temperature, we said that increasing temperature of the atmosphere would lead to that some of it will be absorbed by the water, the sea water, which at a certain point can lead to adversely affecting coral reefs, bleaching of coral reefs, which means they die and turn into white, and the marine life in these areas will disappear over time. That's the main attraction for foreign tourism, as I said. So that's a big question mark. What are we going to do about it in this respect? So I'm just emphasizing the same point, which is climate change is not an environmental issue. Climate change is environmental and development issues. Keep in mind that a lot of the negative impacts of climate change will affect developing countries, which are already struggling with their development efforts and the problems and the issues that they have to deal with. You are talking about a multi-stressors, an additional stressor that being added to the current situation. Okay, that's generally the story about climate change. So the topics that will be covered in subsequent videos, we are going to talk about future scenarios. Why do we need scenarios? What do we mean by scenarios? And what sort of results that we have from such scenarios? We're going to talk about climate change impact. Impacts in here, we're not going to talk about only the primary impacts, but we are going to talk about secondary and tertiary impacts and see how the chain of impacts will unveil. We're going to talk about climate vulnerability. What do we mean by that? How to deal with that? We're going to talk about climate change mitigation, or how can we reduce the emissions of greenhouse gases so that we can delay or halt climate change processes. We're going to talk about adaptation. What sort of adaptation can we have in order to deal with whatever impacts of climate change will have in terms of a certain area, a country, or a number of countries. And the last topic is we're going to talk about climate resilience. How can we be resilient to climate change? What sort of actions can we undertake in order to ensure climate resilience, as well as climate proofing? We need to consider how can we keep our economic activities, people and areas proofed from climate change impacts. Thank you. I hope this video was clear enough. I hope it was worthwhile watching, and we'll see you if you are still interested in the later topics.